Hello and welcome to Analog VLSI Design. My name is Iman Mondal. I am a faculty in the Department of Electrical Engineering at IIT Kanpur and I will be your instructor for this course. A very pertinent question that you might have is why should I study analog circuits at all when it seems like the entire technical world around us is almost fully digital? While it might seem true at a first glance, let me try and convince you that this is not factually correct. We know that all 5 senses that we human beings possess in order to interact with the systems around us or the environment around us are all analog. Take for example, the communication that is happening between us right now. This was made possible because an analog signal, that is the light that is getting reflected from me, and another analog signal, that is the sound of my voice, was getting captured, amplified and transmitted from our end, which the device that you are using is receiving it and amplifying it and presenting it to you for viewing. It is undoubtedly true that there are a lot of digital signal processing that takes place in this entire signal chain. However, undeniably all the interfaces are all analog. As it turns out, the modern cellular phones that we are so used to nowadays contain dozens of analog amplifiers inside them. Also interestingly, most analog systems that we encounter can be understood from the principles governing the operation of an amplifier in negative feedback. Hence, in this course we will concentrate on building an amplifier using negative feedback with a backdrop of integrated circuits or VLSI circuits in perspective. Our overwhelming emphasis of the course will be on synthesizing a circuit right from scratch. We will put ourselves in the shoes of a designer and try to figure out what the next design step will be, instead of taking a circuit that has been presented to us out of nowhere and try to analyze whether it will work or not. We will of course resort to circuit design techniques in order to validate whether our design actually works or not. We aim to be comfortable with seemingly complicated circuits like these by the time we hit the back end of the course, and we will also try to see if this can be improved further. A broad range of topics that we will encounter in our journey and will uncover are shown here. If you are an undergraduate student who has already taken an analog circuit course before or is yet to take one, or if you are a postgraduate student who is willing to hone the intuitions on analog circuits, or if you are an industry professional who is looking to switch over to analog circuits, this course will be useful for you. As a prerequisite, you will need a working knowledge of Kirchhoff's voltage and current laws and their usage to solve circuit theory problems, and also we expect a very basic understanding of mathematics at the level of class 12. Happy learning.